So we face a number of challenges with our work with ClickHouse. I'm going to go through those now. So what was some of the limitations with our ClickHouse-based architecture? So, ClickHouse is famous for being really good at processing denormalized data, but it is, generally has very poor join query performance. And so denormalization was a must. But we have a lot of one-to-many interaction between tables in our data. And so we had a large explosion in the size of our data when we denormalized it. And loading this data into ClickHouse could take hours. And in fact, reloading an entire ClickHouse cluster could take up to a week just because of the load of data. And then we just had numerous challenges at scale supporting all of those different clusters. And at the end, we still had, we still struggled with query performance, especially for our larger customers. There were always a few reports that were always struggling, and where we were always trying to tweak things to make things work better for those customers. So what made our data explode in size when we denormalized it? So let's take a look at some of our data. So we have three main tables that are the core, really core of our data. In the normalized view, we have events. So these could be viewing a web page, downloading a white paper, or going to a webinar. People, self-explanatory. These are the people that these events are about. And then the account is that account-based marketing concept. That company that person belongs to. And so by data size, the events are very small. The people are fairly large, and the accounts are the largest objects per row. But then when we look at the number of actual records, we have very few accounts. More persons makes sense. You'd have several people at any given account or company. But then we have a very large number of events. And so denormalizing these things together means that we're duplicating these person and these account objects, tens, hundreds of times. But those are our largest data records. And so that's what leads to an explosion of data for us and probably many other people doing these kinds of denormalization. So what was the cost of all this denormalization? So it ended up that we were paying more for disk than compute with our ClickHouse clusters. We've calculated that even in a columnar optimized data store, the denormalized data was at least 10 times larger than it was normalized. And in addition to just paying for a lot of disk, we were also needing to pay for the highest performance drives from AWS, to get the highest throughput, the highest IOPS in order to meet, our performance targets. But even with all of this denormalization work, we still had queries that required joins. In fact, most of our queries still had joins. We have concept of membership lists of accounts or persons. And most of the queries that our customers run use one of those lists as a filter. And so we were always joining in that part of that table as a filter in a large number of our queries. And then we had issues with the computation of this denormalized data. The cost of our ETL process of taking the normalized data, doing computation, and then denormalizing it together meant that we could really only run this about once a day. And in fact, for older event data, we usually had to do it only a few times a week, or maybe even only once a week, in order to have reasonable costs and also to be able to just be able to load the data into ClickHouse. Even with the amount of dedicated write resources we gave ClickHouse to do this. And then every time we changed the schema of this denormalized view of the data, adding a column, well, you had to recompute all of this denormalized data again to add that column to it. So it could take a week or more before that data got into the system for all customers. And so, there was a real lag time between trying to add something and it showing up in the product. And then on the performance issues, JSON has always been one of the challenges for us at Demandbase. Again, we have a lot of these big objects. Some of them are quite large, especially some of the custom data our customers bring in. And we found that we really couldn't use the JSON field type in ClickHouse. We had struggles with it. So we stored the JSON as a string and we would parse it at query time. So we were parsing this query at parsing this JSON at query time, so that takes effort. And then this denormalization meant that if we're pulling something from those accounts or persons off of an event from the JSON, we're spending a lot of our CPU resources parsing that JSON, or even more so in the case where we're filtering on something from that JSON. Now you're having to read that JSON from every single object for every single event. And so this could lead to a number of complaints that were just always kind of occurring in the background of various query latencies or struggles from some of our customers. And then there was the efforts of maintaining all of these clusters. And so we faced this constant challenge of our customers would onboard new data. They would their needs would change and grow. And we'd find that we'd constantly need to migrate customers out of an overutilized cluster to a new one. But the things I mentioned about how long it took us to load this huge denormalized data meant that there was a long lead time to moving these customers. So we really had to be several days ahead of there being any problems and beginning that move so that they would be moved off before the problem became more acute. And so we were trying to always be bin packing these customers together, which would either lead to overutilization, low resource utilization, and all of this effort and maintenance that was required was almost a full-time job for a single employee here at Demandbase. So that's when we started looking at StarRocks and specifically the CelerData Cloud offering. So a little bit about CelerData Cloud, BYOC, bring your own cloud, based off of open source StarRocks. And it's a managed StarRocks that runs in our VPC. And this was something that was really valuable to us. It's a managed service, so a lot of that effort is taken off of us, but the data lives in our AWS accounts. It doesn't leave those accounts. And so that from a security perspective and data security, that was really important and valuable to us. And then the CelerData Cloud supports a number of enterprise access control features, especially row masking policies that we've used quite a bit in our efforts. And then because it uses StarRocks, it's designed for joins on the fly to be really part of its internal DNA. And it has strong ability to scale both horizontally and vertically as our needs change. So just a quick look at the StarRocks cluster architecture. So we went from having 40 ClickHouse clusters to trying to do this in just a single cluster of shared CelerData resources. That cluster has a small number of these FE nodes. Those handle the client connections, query planning, those kinds of things. And then a larger number of backend nodes where the actual data is physically stored. And then the compute of those nodes is used to run the queries. And because of this architecture, a query could come in and the resources of multiple BE nodes, really all the nodes that store data that query involved, could be used in executing that query to speed it up. And we didn't need any kind of dedicated write resources. Each BE node was responsible for reading and writing data. And so let's compare that to what we were doing in ClickHouse. So in ClickHouse, we had every one of our clusters had 3 nodes. 2 were identical read nodes, read replicas of each other, and then we had a write node. So we had one node. These 3 nodes were all identical. So we had one third of our resources was strictly for writing data, pulling Parquet files from S3 from our iceberg tables, processing it into the ClickHouse table format, and then loading those into the read nodes. And then each query would go to one of the 2 load balanced read nodes to be processed. And so with that architecture, to speed up a query, the only thing we can really do is, have more resources on that read node, vertically scale that read node. We could handle more queries by having more read nodes, but we couldn't increase the performance of a given query except by scaling vertically because the resources of only one node could be involved. Where with CelerData, we could make use of all the resources of this whole big cluster for every single query, and we had that great horizontal and vertical scaling. Increase the size of the backend nodes vertically, and just add more BE nodes to scale horizontally.